Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 2, we will talk about planning strategies. The different concepts that we will cover in this particular lecture is need for planning, design period for utilities, population forecast and land use forecast, engineering design options, siting of infrastructure, service level benchmarks, and data and surveys. So, why do we need to plan for water supply, sewerage and drainage infrastructure, and what is the primary needs when we that has to be addressed when we plan for this particular kind of infrastructure or utilities. The demand and fluctuation in water consumption is, as we have already learned from our previous lecture, the demand and fluctuation in water consumption is intrinsically linked with sewage generation. So, that means the amount of water or the variability of the water that is being consumed by a particular society or a particular population group or in a particular area is linked with the amount of sewage that is generated. Thus, consumption of water and water supply and sewerage infrastructure provision are also linked. So, based on the amount of water that will be consumed in a particular area and of course, the variability of that consumption, water supply and sewerage infrastructure provision has to be decided based on that. Consumption of water depends on population, land use, climate, affluence, etc. So, how much water will be consumed by a particular area depends on the population who lives there, the land use of that particular area. Why land use is important? Because some areas may have more green spaces which needs to be watered compared to other places and so on. Climate of that particular area, is this particular area located in a dry region or in a cold region or in a area which has lot of, is it a coastal area or the area which gets lot of rainfall and so on. The affluence, the more affluent a society is, the more rich a society is, the more amount of water they will require. They will require water for the swimming pools, they will water to clean their cars and so on, right. Similarly, availability of water supply and sewerage infrastructure influences land use and population of an area. So, this is an interesting thing. So, based on the demand we have to provide certain kind of infrastructure, but based on the infrastructure also the land use or even the this population for a particular area will actually vary. If a area does not have infrastructure or utilities, then people will not come to that particular area or they will not choose to locate in that particular area. So, it is a two-way link, right. So, land use and population forecasting is an inherent part of utilities planning. So, first we need to understand how much land use, how the land use will change for this particular area or the evolution of land use in that area. Population forecasting, how much population will grow for this particular area. Then the quality of utility infrastructure and services depends on the affluence of population. Based on the society or the amount of money the society has got, the quality of utility infrastructure and services will be decided. Based on that, we will provide certain kind of infrastructure. Certain technologies that would be adopted or certain engineering designs would be adopted based on the amount of money people would be able to pay for those kind of engineering designs, right. Because funding has to be there, the funding has to be secured from the people from whom we will supply this kind of services. Similarly, conservation and reuse behavior is also linked to education and affluence of the population as well. So, educated people, more affluent people, they are more prone to conservation or reuse of water resources and all. They understand the challenges, they understand the scarcity of water. So, based on that also the total the consumption as well as the overall water use for a particular area will vary. Then sewerage and drainage infrastructure has lot of overlaps. Sewage is sometimes conveyed with stormwater, and storm flows, but sometimes it is separate. So, either we have a combined sewage system or we have a separate system, and storm flows actually needs to be routed separately and also regulated before its final disposal. It could be with or without treatment, but if we do not regulate this, if we do not control this, then it will flood the entire area and that will lead to a lot of damages. So, degree of severity of a storm, storm means a rainfall event, degree of severity of a storm, both rainfall intensity and time determines the amount of storm waters that is being generated, amount of water or rainfall that is generated, because if the rainfall is very intense for a short period of time, in a short period of time you will get a lot of water, and that will not be able to get into your drains because your drains may be not designed for that. So, it will overflow and that will create floods, right. So, this is something which we have to be aware of, and we need to design our infrastructure considering all this. And then flooding results, and because of flooding it results in severe damages to life, property and infrastructure, which we will always like to prevent. So, when we talk about utilities planning, there is a fundamental difference between the standard planning of land use or transportation or other things. The reason is, when we talk about utilities planning, of course, the standard planning attributes, for example, how much is the performance of the plan, that means how much area the plan covers, what kind of demand the plan is going to satisfy, all this, the performance of the plan. The efficiency of the plan, that means how much we are getting back for the money that we are going to invest, right? Or how efficient is the plan, or in, like how much amount of water is going to drain out, like is it able to drain out 90% of the storm water, or is it going to treat 80% of the storm water. So, these are efficiency levels. The environmental impacts of our plan, the health impacts of our plan, the social implications like equity, acceptability, is that particular infrastructure acceptable, because it may harm some groups, or then we talk about equity, if water supply is available to everybody in the city, right. Then the cost of provision of those kind of services or utilities, right. So, all these things are part of the overall plan that we will prepare for our urban utility for a particular area. But in addition to that, whenever we are talking about utilities planning, the second thing that comes into play is the design. That means the engineering design of that particular utility infrastructure that we are talking about. For the same thing, we can have different designs, and each one will have their pros and cons, and also cost. So, there will be some benefit to certain designs, but it may come at a higher cost. So, we have to choose the right design, and sometimes certain designs are good for certain climate and certain geographical characteristics. So, that also needs to be understood. So, if we provide a very sophisticated system in an area where there is no understanding or no appreciation for that kind of a system, there is no point of providing that system, right. So, engineering design is also a part of utilities planning. Then the next step is and of course, design means options, acceptance of that design, willingness to pay for this design, all these things will come into play. Now, of course, the design itself is the most important, and to learn what sort of options are available, the technology options and the design principles behind that. So, that is also that we need to also understand. Then comes implementation. Implementation could be of different types. If it is a pipe network, then we can talk about how do we phase, that means this phasing would be linked with land use growth and so on. So, phasing is one part we need to understand. That also requires us to make sure that we have adequate money to phase it or construct during that particular phase. Permissions and clearances that are required, right. The agency who will implement that particular project, right. So, implementation is all about execution, right. So, in what mode or in what structure, management structure you will execute? Is it done by the government? Is it done by a private company? Is it done with a PPP model or a public-private partnership model, and so on? So, this implementation is also is very important, because utilities has to be provided by the government, and when you plan for utilities, you need to think about how you are going to execute that, where you are going to get the money for all this investment, where you are going to get your loans and all this. And then comes operation maintenance. I was telling you in our previous lecture that most cities, what happens, the capital infrastructure, the capital investment is made, the infrastructure is created, then there is no operation and maintenance. But utilities planning is all about operation maintenance. After construction, the utility will run for a long period. So, during that period, it has to be operated and maintained, right? So this operation and maintenance is very, very important, and that if the cost of operation maintenance is not viable, then we actually need to change our plan. Or similarly, if the design is not viable, we need to change our plan. So all this, there is a feedback coming from operation maintenance and the design going back to the first planning stage. So operation maintenance includes also feedback on service quality. That means operators or utility providers actually take feedback of people to see if they are happy with the services, or what are the services that are lagging that has to be improved. They set tariffs, how much amount of cost that they will set. So all these are also part of utilities planning. So how do you determine cost for services? How do you determine improve service quality? Then what are the different operation management, the engineering part is also there, right? How do you maintain a particular infrastructure and so on, but that part becomes more technical and more from the domain of actual engineering design. So the major challenges when we talk about utilities planning are population growth, because particularly in cases in our country or developing countries, the urban population is growing at a very rapid pace. So whatever infrastructure we plan, it has to be adequate for not only current population but also future population. Urban unplanned growth, because of certain issues, certain areas of the city may grow or development may come without proper planning. That means real estate developers may speculate, and then they start developing in a particular area, and then the city catches up by providing infrastructure and so on. So all these issues are there. Then improper design, lack of coordination among stakeholders, and holistic planning, absence of holistic planning, and climate change. So these are the major issues that we have to deal with when we do utilities planning. So the first thing that we need to understand when we do utilities planning is the design period. That means, because these are big capital investment, this require a lot of and this investment is not for a few years, it is for a long period. And this usually we consider that water supply, sewerage and drainage projects are designed for around 30 years. But not all parts of the infrastructure is designed for 30 years, but most of it is designed for 30 years after completion. Sometimes the project itself takes 5 to 10 years to 5 years to construct. So if that means from the beginning of the project, it would be 35 years. So that's the standard life of a project. For any kind of costing or trying to determine any kind of plan where we have to pay interest for a particular, for where we take a loan and we have to pay interest, we will consider a 30-year period for that particular infrastructure. So the design period can be modified as per useful life of component and structures. So basically, some of the components and structures could have a lower life. For example, a pump house or a pump station or pumps actually cannot run for 30 years. Usually they have to be replaced within 15 years. So electric motors and pumps has to be replaced by 15 years. Similarly, water and sewage treatment units because these are mechanical units, this has to be replaced within 15 years. So according to that, we will decide. But in general, most of the things are 30 years, like infiltration works, pipes connections to several treatment units, rainwater and clear water conveying mains, right, the major pipelines, and distribution system, these are all 30 years, right. Whereas this overhead reservoirs, service reservoirs, these are again for 15 years, all right. So this is that is how the design period actually plays a role in determining what kind of plan that we will prepare. So design life is more, now there are certain conditions where the design life could be extended or reduced. So in case we understand that there will be very, very difficult in expanding a particular project, because suppose it's a very dense area, we are laying a pipe network, we know that even after 30 years it would be a big challenge to improve that. So we will try to design the infrastructure or extend the life as much as possible, right. So that is then based on availability of finances. If there is not much money, then it would be a shorter design period. If we can make sure that there is adequate money, then we can go for a longer design period. Now, why longer design period? Because the more long the design period is, the more would be the size of the infrastructure, or the amount of money that would be required to construct that kind of infrastructure would be higher. For example, if you are planning to keep your sewerage network for 50 years, obviously it is the size of the drains and all will increase, because population will be higher, or more areas would be added by another 50 years. So, right now the investment would be higher. Then rate of interest, usually most of these infrastructure projects are taken based on loans given by different agencies, could be our own government, could be some grant agencies which gives grants, and some international agencies and so on. So, in that case the rate of interest plays a role, and if the interest is low and it is given for a longer design period, that means the loan is given for a 30-year period, obviously my life could be extended. So, that actually plays a role in deciding on for how much years we will actually plan our infrastructure. Then population and land use growth, less change than longer design period. So, if there is not much change in the population, not much change in the land use, then we can plan for a longer design period. Because if it is not, if new areas are being planned and all, it is most likely that our design will fail. So, as we are designing, or we have to take a very, very large so for example, for pipes we have to actually increase the pipe diameter by a huge margin, so that there is no chance of failure, and actually that may be a wrong design also. So, population and land use growth, if it is more or less stable and we know that it is going to be remaining same, we can also extend the design period. Availability of land for future expansion, that also plays a role. So, next we will talk about population forecasting for a particular area. It is essential to determine population and land use growth and intensity of development in different zones of the planning area. The reason is because certain areas may get the intensity of development may increase, that means the more number of people may start coming into that area, but because of the pipelines are already laid, probably it is not it will not be able to support more number of people, right. So, that is a possibility, but we need to forecast beforehand that what would be the population in future, or what kind of land use or intensity or land use development will take place, and accordingly we need to plan our infrastructure, because once we plan it, it will be there for 30 years. So, we cannot augment it just like that, all right. So, usually population forecast, land use forecast becomes very, very important in utilities planning, and there are several methods to do this forecasting. There are mathematical methods, then there are economic methods, then there are other methods as well. So, we will discuss briefly about some mathematical methods and maybe some economic methods, but if you want a details discussion on different kinds of projections that we used in planning population forecasting and all, you can actually follow these lectures from one of our other NPTEL courses, which is population forecasting method, and the links are given over here. You can actually go into those links and look into the details. So, first we will discuss mathematical methods, which actually there are several mathematical methods. There is the arithmetic increase method. Most of you are aware of this. That means it is the linear growth method. That means we will assume the similar growth will happen for all the years. Then there is a geometric increase method, incremental increase method. These are the two methods that we will discuss today. The logistic curve method, which is similar to one of it is another we assume a logistic curve instead of a geometric progression and so on. And then there is a graphical method, that is by observation. So, first looking into the geometric increase method. Okay, before I go into the methods, in general mathematical methods or mathematical models predict population using the population growth rate from a past period based on the data that is available to us, or from similar kind of population groups in similar areas with similar characteristics, and we adopt their rate and apply that for this particular area. Now, what this means? That means that if everything remains as it is, the similar kind of growth is happening, similar kind of changes are happening, then this method is most appropriate. So, two things, this method is applied if population growth is regular and there is no major societal and economic changes. So, suddenly if a big industry comes to this area, or suddenly there is a huge change, maybe a disaster in this area, it will not be able to predict future population growth, future land use growth and so on, right. So, it is just based on what has happened till now. So, these are used for short term forecasting, and other thing is it is no consideration of the different age groups, gender groups or the population subgroups. So, we assume that same thing will happen for all the different population groups, which is also not the case. But again, these are simple methods. If you want to really do very fast forecasting, this is the way to go. So, again within these methods, each method has got their pros and cons. I will discuss some of that, but you have to take a call on which method you want to use. So, arithmetic increase method, all of you more or less know. So, I will start with the geometric increase method, where we see that Pt, which is the population at time t, is equal to P0, which is initial population, into 1 plus m to the power t, where m is the average geometric rate of change or geometric mean, and t is the time in decades or the number of periods in decades, right. So, what does this mean? That this means that if I want to predict my population 5 decades down the line, or that is 50 years down the line, or 3 decades down the line, I have to assume a particular growth rate of population growth. So, that is m, and because it is geometric growth, so that is why I have taken 1 plus m to the power t. So, that is why a power function is taken, and m is basically the geometric mean. Geometric mean of between each time period there is some change in the population, we take the geometric mean of that. So, that is the only difference. In arithmetic progression, arithmetic increase method, we take the arithmetic mean. We just divide all the growths are divided by m. Here we take the geometric mean. So, that is the difference for a geometric increase method. Then we have the incremental increase method, which takes into account both the existing growth that is happening and also the incremental growth. So, that is given by Pt, which is again the population at time t, is equal to P0, that is the initial population, plus t is the number of decades that we will consider, into mi. Mi is the rate of increase for each decade. So, rate of increase for each decade is the arithmetic average of each increase for each decade, and then I have got t into t plus 1 divided by 2 into k. So, again t is the decay in decades, and k is basically the rate of change in increase for each decade. So, we understand that even though there is increase, but in each subsequent decade the increase rate will change, right. So, we are also considering that part. So, this is somewhere between the geometric method and the arithmetic method. I will just give an example. Let us see that let us assume that in the year 1971 a particular area has got a population of 54,000, in 1981 it was 66,000, in 1991 80,000, 2001 1 lakh 1,000, and 2011 1 lakh 20,000. So, this is the data that we have got. Now, we have to predict the population for the year 2031. How will we do that? First, we determine the increase every time decade. So, if we see in the first decade 71 to 81, there is increase of 12,000 population, then 14,000, 21,000 and so on. So, if I have gone for a arithmetic method, then I would have taken all this increase divided by the number of periods for which increase have been recorded, and we get the rate of increase as 16,525 people per year. So, we will multiply that with that number of decades and we will get the arithmetic using the arithmetic increase method, we can get a final population figure. But because we are using the incremental increase method, in addition to the arithmetic increase, we are taking the incremental increase. So, between these two increases there is change of 2,000, between these two increases there is change of 7,000, and then there is a decline. So, this actually takes into the account of the gradual reduction of rate of change as well. So, when we take these 3 decades, we add this 3 up and we divide by 3, we get this is the k value or the incremental change value, the average incremental change value. So, now when we we determine the population for the year 2031, we take the base population, which is 54,000 from 1971, then there are 6 decades, this is first, second, third, fourth, then 2021, fifth, and then 2031, sixth. So, that is why 6 into the arithmetic increase. So, 16,525 plus 6 into 6 plus 1 divided by 2 into the incremental increase, that is average incremental increase, that is 2367. So, here we get a population figure of 1,88,655, which is the predicted by the incremental increase method. So, in 2031 the population would be this. Now, if I have used this particular method for predicting population using both geometric increase, arithmetic increase and incremental increase. This is the graph that you would have seen. So, this gray line is the incremental method, this sharply increasing line is the geometric method, and then the almost flat line is the arithmetic increase method. So, you see that incremental increase is somewhere between geometric and arithmetic. So, in cases a city is growing very, very slowly and all, we will probably go into use the arithmetic method. If a city is growing exponential, there is lot of new businesses coming in, lot of new companies coming in, probably we will go for a geometric method, or otherwise we will go for this incremental increase method, which seems to be the most appropriate. But all this is possible when you assume that the city is more or less growing in the same way as it was in the maybe in the previous couple of decades. And this kind of prediction also could be taken for shorter time spans. Now, we have then comes the economic methods. In economic methods, it is suitable when economic events plays a major role in an urban area in a time period, and that basically means is when lot of changes is happening in an urban area which was not there in the earlier time periods, new companies are coming in, we need to consider the economic events that is happening in that particular area. And for that there are several methods, again the employment method, ratio method, migration and natural increase method, cohort survival method. So, I have already told you that all these methods are covered in details in some of my earlier lectures in another NPTEL course. So, I have given the link for that, you can follow that. Otherwise, we will talk about these two methods, migration and natural increase and the cohort survival method. Actually, these two are more or less the same method, but different ways of representing that. And employment method and ratio method, briefly I can tell you that based on the employment rates, we can determine what is going to be the population rate for an area, because employment attracts more people to an area, employment also ensures population growth and so on. So, employment method is there. Ratio method is taking the ratio of growth between 2 decades from a similar area which is showing similar kind of trends and applying it to a particular area. That basically is the ratio method. But migration and natural increase method is the most popular and the most appropriate way to go, where migration and natural increase both are considered. That means the population change after a certain period n with respect to period t considers that both birth that happens in that particular city, deaths that happen in that city for the existing population, and the number of population that is in-migrating and number of population that is out-migrating. That is number of people coming into the city, number of people going out of the city. So, the total number of people that the population change is Pt plus n. This is the time period which is after a period of n, and minus Pt. Pt is the initial time period. The change is equal to birth minus death plus in-migration minus out-migration. So, this is how we will determine the population for a particular area, and this migration is actually influenced by economic growth. Sometimes new companies comes in, lot of new migration will happen. This new migration, lot of people will come to work in these industries with their families or without their families. And if there is no industry, nothing, then there is a lot of out migration. People will go for studying, people will go for work. So, these are the things that has to be estimated along with the natural birth and the natural death rates for that particular community. But still, this is this kind of method is still crude, because here we assume the entire population together, right. So, that means for the entire population we cannot have the same birth rate. A 90-year-old person and a 35-year-old person cannot have or a particular person can have similar kind of chances of death or that is happening. So, a person who is 90 years old has a more chance to die, or the mortality rate is higher. So, similarly for birth rates also it varies as per the age group of the female population. So, for certain age groups there is more chance for live births, more chance for births. So, in that way we go for a cohort survival method, where we break down the entire population into different age groups or gender groups, and then we can follow this kind of method where we estimate the birth, death, and again in migration, out migration for each of those cohorts, and then we can predict their overall population for a particular urban area. I will show an example. This is again from our earlier lectures. So you can see in this particular table, look at the headings. So initially we have got existing population. The population is broken down as per different age groups and also as per males and females, as per gender. So you see that at 0 to 4 age group, there is around 611,84,852 males and 5559,6970 females. Now, ABSR is basically the age specific birth rate, and number of live births per 1000 female of a particular age group. Now, obviously, a female belonging to age group 0 to 14 will not give any live births or not give any birth. So, the birth rate starts from around 15 to 19 age group. So, we see that the ABSR is around 391 for the 15 to 19 age group. For 20 to 24 age group, it increases to 491.7. Same for 25 to 29. Then again the birth rate goes down. 30 to 34, it's 287.8. 35 to 39, it is 86.4. That means 86 live births per 1000 female, and then 40 to 44 around 9.5, and then almost nothing. So, after 45, 49, 44 we do not see too much of any birth. So, from this we can calculate the total number of births that happen. So, based on the this birth rate, and this total birth is added up and this is brought over here. Now, mortality rate also is calculated for each of this age group. So, obviously, the mortality rate is high at very low age 0 to 4, it is 10.9% for male and 12.10% for female. For 5 to 9, it gradually reduces, drastically reduces to 0.90 and 0.80. Then it further reduces to 0.40, 0.20, and then more or less remains same till the age of around 59, it remains same. Then it increases. From after that, the chances of death is higher, which is around 4.44%. And so, based on for female and 5.28% for male for the other age groups. Obviously, if you have more data, you could have even replaced these figures with more appropriate figures for each group. So, roughly you can see that the chance of death is different for each of this group, and we predict the number of deaths from each of this group, and this is the number of deaths for male and female for 0 to 4 years of age and subsequently for that. And once we have that, we can remove the deaths from the population and we can have the remaining population. So, this is the remaining population for males and females for each of the age groups. And after that, we have what we do is the new births is taken to 0 to 4 age group, and then we divide it into male and female. This total birth is divided proportionately into male and female based on survey data or based on available data from medical records or hospital records, and we get this new group of people in the 0 to 4 age group for this particular area. And what happens for the other one, 0 to 4 age group will go to the next group, which is 5 to 9. So, this is after a time period of 5 years. So, we are projecting the population after a time period of 5 years. So, obviously, whoever got whoever was born in the previous 5 years becomes part of the 0 to 4 age group. The existing 0 to 4 age group becomes 5 to 9 age group, and everybody is transformed into the next group. So, the final age group is 100 plus. So, it can take into care everybody who is left out from the previous age group. So, in this way we can actually predict the birth rate, the birth or the change in the number of people in both male and female for each of this age group, and why this is important. And we can go for 5-year steps or 10-year steps, and in this particular example I have not taken the in-migration and migration example, but that also could be done in exactly the same way for each of this group, because they also have their mortality rate, they also have their birth rates and so on. And once we have done that, what we have is we have got different projected population also for each age group and each gender group, and this can help in determining group specific policies for reduction of consumption of utilities and services, or their behavioral changes would be different for each of this age group, and as per that we can also do a lot of calculations or a lot of projections in future. So, this is the most appropriate way to project the future population, but as I have told you, based on the appropriateness, based on the kind of policies you are going to undertake, or based on what you are actually measuring, based on the requirement. Like if you are just determining what is the total volume of water required for a particular area, you just need to multiply the overall population with the liters per capita per day. In that case, I will not require this kind of detailed calculation. But if you want to take behavioral measures, or you want to determine what kind of changes you can bring in reduction of water consumption among different age groups, probably you have to predict the future population for each of this age group. So according to the requirement, you will use a particular population forecasting method. So we will end our lecture over here, and so we have learnt about how to focus population, but in the next lecture we will actually continue with the planning strategies, and there we will start with population forecast. Thank you.